All right, I just want to talk to you about friction. So, what is it? Well, there are two kinds of friction. There's static friction and kinetic friction. Static friction is when there's no sliding between solid objects. So, for example, if I have this book here, and ignore the book for a moment except for the fact that it's slanted, and then I put this chalk on top of it, right now, if the book were instead a sheet of ice, you'd imagine the chalk would just slide down it. So there must be some force keeping it from sliding. And so we have static friction, static, it's not moving, friction keeping the chalk box from sliding down, and the direction of that static friction force is in the direction opposing the motion. So it wants to slide this way. The static friction force is pushing that way. All right, let's put this to the side for a second. Right, so this prevents sliding. So you can always figure out what direction the static friction is if you imagine a world without friction and see the direction of sliding, say, the friction force is opposite to that. And so there's an equation for the force law of static friction, and that is F of static friction. And I'm just going to look at the magnitude here. So the magnitude of static friction is always less than or equal to mu s, and this is called the coefficient of static friction times the magnitude of the normal force, because the normal force is perpendicular. In this case, the normal force is perpendicular to the surface. Normal means perpendicular. So they're not in the same direction, but you can figure out the size of the static friction force from the normal force. At least you can put a limit on the static friction force like that. Okay, and then what we have is kinetic friction, which you've probably experienced. So if you rub your hands together, they don't seem like they slide perfectly. And that's because there's this kinetic friction. So, for example, here, if I tilt the book, let's go like this, put it right here. If I tilt it, we have static friction, and then eventually it starts sliding, but there's still some resistance there. And that's kinetic friction acting. So kinetic friction acts when there's sliding between solid objects. And I'm talking about solid objects because later we'll talk about drag, which is sort of a friction for fluids. And this is opposing motion, but not preventing it, because the chalk did slide for the kinetic friction case. And there's also a force law here, and the magnitude of the kinetic friction is equal to, not less than or equal to this time, equal to mu k, which is the coefficient of kinetic friction. And then again times the magnitude of the normal force. And so you might have experienced this if you're pushing a refrigerator, right? You originally have some pushing. If I'm pushing this here, we have some static friction that keeps it from moving, and then when I start pushing this tiny chalk refrigerator, there's some force resisting me. But the interesting thing is that the kinetic friction is actually less than the static friction at its biggest. So if you imagine pushing something really heavy, you'll realize it's really hard to push, and then once you get it moving, you've got it moving. It's a little bit easier. And so that's what this picture down here is showing. So the situation we're thinking about is if you have the ground down here, and let's say you have your refrigerator that your friend is making you move, and you're pushing it with some force of, well, let's call it pulling. You're pulling it with some force of pulling this direction. And so the force that you have to apply to this, if you're constantly increasing it, you get up to some point. So this is all static friction. right? The graph here is the force that you apply, and then this is the frictional force right here. So as you apply force to it, I'm pushing this thing, or you're pulling the refrigerator, you're pushing and pushing, or pulling and pulling, and it doesn't move, and then we get up to some point here, and then the amount of friction force pushing back drops down to be less down here. So since friction, static or kinetic, is in the direction opposite to the force we're applying, or the direction that the motion would go in if the floor were ice, we know that the friction force, so this is force of friction, will be in the opposite direction. So I hope that helps get you started understanding what friction is.